Hello, hi, welcome to the new lecture. So today we will learn about B numbers, LAR, least absolute residue of modulo M, and some other concepts. Okay, last class, at the end of the class, we have seen that basic about fermat factorization. Okay, so in this fermat factorization, we will upgrade to it. Okay, we will move means upgrade version of fermat factorization. We will see about it. For that, first you require this small concepts, small terminology, that is LAR, what to know about LAR, and B number and factor base. Okay, so in LAR, what do you mean LAR? LAR means least absolute residue. Okay, least absolute residue. So we need to find LAR of a mod n. Mod n means you have to read as modulo n. So now we will discuss about this one. So this value is nothing but means LAR of a mod n equals to b. Okay, such that where b is congruent to a mod n and this b range b should be belongs to minus open n by 2 to closure n by 2, that is minus n by 2 less than b less than. Okay, samjha? One kick I will give to myself. Okay, so after this one, this is what you have to see, bro. Simple. Okay, simple, very simple. A mod n. Generally, if anyone asks, bro, what is 3 mod 2? What will you say? Answer is 1. If anyone asks, let's say 29 mod 15, what is answer? 14. Okay, so the way which we have brought up means the way from our classes, the way how we define means a mod n means the value will be always will become 0 to n minus 1. This value, output value, will be always 0 to n minus 1. I mean, this can be written as 0 to n open bracket. This is closed bracket. So now this LAR residue absolute modulo, it's saying that the output range should be in minus n by 2 to plus n by 2. Okay, this is what output value saying. Okay, that's it. Means if you observe that, if anyone asks you what is LAR of 29 mod 15, first normally calculate means normally how will you calculate 29 mod 15 means you will divide with 29 15 14. Okay, answer will be 14. Now tell me, if check whether 14 is greater than 15 by 2 or not. If it is greater than 15 by 2, yes means then subtract 14 minus 15, so value will become minus 1. So therefore LAR of 15 is equals to minus 1. Okay, this is how you have to calculate. If anyone asks you what is LAR of 19, normally calculate it. Now compare whether it is greater than 15 by 2 or not. If it is less than 15 by 2, no problem. That is your answer. Samjha? Suppose let's say 36 mod 15, LAR of 06 mod 15. How much value? Tell me. 6 normally calculated. Now check me whether 6 less than 15 by 2 or not. 15 by 2 is 7.5. Yes, so less than. So therefore our answer will be this only, 6 only. So like this, okay. So LAR of A mod n, LAR of A mod n equals to A mod n minus n if what? Tell me. If the value is greater than n by 2. Let's call it as A mod n value as some k or some m. So its value will become m minus n if m greater than n by 2, or this value will become m only if m is less than n by 2. This is how you have to calculate. This is what you have to remember. Okay. Okay, go to next concept. What is B number? So what do you mean by B number? So B number definition. B number, so we will say like this: for a given n, so B number we call small b. Let b be some name of the b. B is a B number. What is the definition I'm telling? If LAR of B square mod n equals to pi into j equals to 1. Let's listen it. I will tell them. Pj into alpha j. Okay. So this is called B number. So for this you need to understand what is factor base. Okay. Factor base. So factor base is, let's say factor base is a set basically. Okay, let denote set by b. Let's say set b. Okay, b is called b is nothing but the factor base definition is it is set of distinct primes. That's it. This is the set of distinct primes, and generally we write this set in a ascending order. What? Ascending order. So basically factor base is nothing but distinct primes, like you can think of 2, 3, 5, 7 distinct primes which are generally that definition itself, generally we keep factor base in a descending order to avoid confusion. Okay, that's what you have to understand it. Okay, so you can, if you want a real definition, I can write like this: factor base is a set of distinct primes p1, p2 and so on pn, where all pi's are distinct. Okay, that's it. Here remember that the beauty means this corner case you have to remember this, that key in p1 can be a minus 1. Okay, p1 can be the minus 1. That's what you have to remember. Generally see 2, 3, 5, 7, this is a factor base. Yes, because all are in ascending order place. These are in ascending order is just our convention. Leave about ascending order. Think all are distinct primes or not. Yes. Okay, fine. So this is also the factor base. Samjha? You understand what I mean to say? Factor base is nothing but it's a bacha set as a set having a distinct primes. That's it. Okay. So let's say you have given n and a factor base. Your job is that check whether some integer, let's say some integer, name it as small b, some integer, check whether b is a B number or not. What? B number or not. So the answer is, how to check means b is a B number if you can able to express a LAR of b square mod n in the factor base. In the factor base means something. Let's say factor base is p1, p2 and so on. Let's say ph. So if we can express this in the factor base means p1 power h1, p2 power h2 and so on, pn power hn. Then you can call it as a what? The small b, not the small b as a b number. Samjha, you understand my point, what I mean to say? If you want to really feel it, I can give an example. Okay, now for a given n4 is equals to 3 and capital B, this is the factor base. Check whether 67 is B number or not. This is the question. Okay, now how to check it means answer. How to do it means first find the LAR of b square. This is, let's say this is called small b. So 67 square mod n value is 463. I am just applying this formula. So calculate this one. How much you will get answer? Tell me. LAR of 67 square. So if you compute 67 square, 4489. Okay, now what is the value of this one? It's nothing but generally, let's say just this value, let's name it as, let's say just go m. What is the value of m? M equals to 4489 mod 4633. So m value 4489. M value is greater than n by 2. N by 2 means 4663 by 2. So your answer is what? 4489 minus 4633. Okay, so therefore your answer will be minus 14. Therefore LAR of 67 square mod 4633 value will be minus 1.4. Now the question is that will you able to express minus 114 in terms of, in this factorization means minus 1 whole power some x and 2 power y and 3 power z. Okay, now the question is, so I am writing like this means can I express 114 as like this or not? That's what I am asking. I am asking you, you have to tell me. So just tell me, just means just for fun factorize. Okay, what will happen? Tell me. 12, 7, 2, 2, 2, 6 and 6 square. So 2 square into 6 square, 2 square into 2 into 3 whole square, that is 2 square, 2 square, 3 square, that is 2 power 4 into 3 square. So this is 114. So minus 114 will be minus 1 into 2 power 4 into 3 square. So can I able to find these values? X, Y, Z. So X is 1, Y is 4. Yes, if I am able to find it, then I can say since minus 1 over 4 is exactly equals to minus 1 whole power 1, 2 power 4, 3 square, minus 1, 1. This is true. So I can say that 67 is a B number. Samjha? You understand my point? Like that you have to check it. Okay, very dead easy. Means can you able to express 67 in terms of the set B or not? That's it. It's not a 67 you are expressing, it's a LAR of 67 square. You got my point? LAR of 67 square with respect to modulo n. It will be given. So this is the concepts. So you understand these concepts now, right? One is LAR, B number, factor base. Okay, that's it. So LAR is nothing but least absolute residue. So generally if anyone asks normally what is the least, not absolute, least residue, modulo of 37 mod 3, what is the answer? Your answer should be 37 mod. So your answer is nothing but whatever you calculate in the normal way. That means answer should be always in 0 to 3 minus 1, that is 0 to 2. In this interval your answer should be there. I mean, okay, you got my point. So this is nothing but whatever you know already. Okay, this basics only means 337 means this is nothing but reminder when you divide it with 3. So it will be like how much? 12 36 1. So answer will be 1. So least residue means nothing but a normal answer. Least absolute residue means it should be in the range of minus n by 2 to n by 2. So for that it's nothing but this formula. Okay, that's it, bro. So go to next concept. Now we will see about fermat factorization. So we will see about only few things, okay, in this thing. Remaining we can see in next class. Okay, so see here, let's study it. Consider the set of B numbers. What? Set of B numbers. So first step is that consider the set of B numbers. So capital B is written as, for you I am expanding very big one. Simple concept only, just listen it. Okay, this is the set of B numbers. Okay, you got my point. This is not the factor base, this is the set of B number, means set of B numbers with respect to modulo, let's say n. Okay, and a given n. The factor base, okay, set of B numbers, let's denote by set of B numbers, no? Let's say denote set by n. Okay, and let's factor base means B is written as P1, P2 and so on, how many till PH. This is the factor base. Set of B numbers, set of B numbers and given n. This is what you have studied. Okay, now they are saying that since these are numbers, can I write like this? B1 can be written as P1 power something, P2 power B1 square, I mean of course LAR of B1 square mod n, P1 power, P3 power, PH power something. Okay, now similarly I can write LAR of B2 square mod n is equals to P1 power something, P2 power something, P3 power something, P4 power something and so on, PH power something. Okay, after writing this, now here observe this whatever exponents, let's observe for B1 it may be something, B2 it might be something. So to avoid confusion, means to make our life simplicity, we are defining like this. Means when I write like this, means these exponents are denoted by like this, alpha ij. Means when I write alpha 2 1, okay, this 2 indicates the B number, second B number, that is B2, second B number related, and 1 denotes that it is an exponent of P1. Okay, basically alpha 2 1 is a what? Exponent of P1 in the B number P2, in the B number B2. Samjha, you understand my point, what I mean to say? This is how let's say we are defining. This is what Sarah has defined. Okay, very simple. Alpha ij means this is how you have to understand. First number denotes b number, and second will be denotes the, in that particular b number we are having the factor base. In that factor base, which prime number exponent this value will be is. That's what it signifies. Okay, now see, you know what is vector? Vector is nothing but set of tuples. What? Set of tuples. See, the concept of vector you have studied in where you have studied. You studied in the normal bacha colleges. Samjha? Bacha colleges में, I mean 10th class or 12th class you have studied in physics. Means if a vector can be written as like v bar equals to x1 I cap plus x2 j cap plus x3 k cap, and slowly this also another way to represent it can be v bar is just writing in this way, just writing the coefficient. Okay, and next this is the same concept you have extended in the linear algebra. What? In linear algebra you have studied vector. So vector is like nothing but it's basically a tuple. A tuple means like this, keeping brackets is called a tuple. A tuple having the many components means this vector is having 3 components. What you can say, this vector is called having 3 components. Similarly, we are defining like a vector alpha I bar. So alpha I bar is nothing but a set of basically it is a tuple having the how many components? H components. Means it's basically a list of all the exponents of the ith b number. Okay, you got my point. Alpha 1 bar denotes that it's basically all these coefficient together in the tuple. If you write it, if you call alpha, so you can write alpha I bar as how alpha I1, alpha I2, alpha I3 and so on till alpha IH. Okay, I told again, alpha, whenever you say alpha I2, okay, I is nothing but b number, ith b number, ith b number, and 2 denotes that the power of, this is an exponent of the base p2. That's it, no? p2 power alpha I2 in the b number b. Okay, there's so much of repetitive content. After finding defining epsilon I bar is a vector. What is epsilon? Epsilon I bar is nothing but alpha I bar mod 2. Okay, see, you understand this mod 2 concept? Means if you given 25 mod 2, what is the answer? One way is that to calculate brute forcely 25 means normal routine rudimentary method means 1. If you given any let's say 12 mod 2 0, normally you can, some easiest way is there to compute mod 2 in integers. How means, if anyone asks 25 mod 2, if it is odd number, right, for odd numbers answer is 1, for even numbers answer is 0. Samjha? So if anyone asks 3684 mod 2, since this is even number, answer is 0. So this is the simple trick. Okay, now what I mean to say is alpha I mod 2. This means this is my notation. Samjha? It's my notation. Actually it is nothing but alpha I1 applying mod 2 for each of this component. Remember that this is called as vector. This is whole thing together called as a tuple or vector. Okay, a tuple, we will say this is as a vector, and vector is nothing but a tuple having the H components 1, 2, 3, 4 and so on. So this is called one component, another component, another component. This is my terminology. Okay, fine. In the terminology I am saying that apply mod 2 for each every component, means alpha I2 mod 2 and alpha IH mod 2. By applying all this you will get a epsilon I bar. Okay, that is how SAR defined. So again you know that mod 2 is nothing but you can think some trick is there, that if it is if alpha is basically even number, then answer will become 0. If alpha is odd number, the answer will become 1. This normal trick I have discussed. Okay, chalo. Now see, now tell me how many numbers you are having. B1, B2, this capital N, how many numbers you are, BK numbers are there and so on, BK. So see, for B1 we are having corresponding alpha 1 vector, alpha 2 vector, alpha 3 vector, alpha 4 vectors and alpha 5 alpha k vectors. Alpha vector is nothing but it denotes that powers of factor base. Samjha? Powers of factor base. Okay, powers of factor base for the B1 number. Okay, that means if you find LAR of B1 square mod n, that is, it can be written as P1 something, P2 something and so on. That something if you write in a tuple, means then that is called a vector, alpha 1 to alpha. So correspondingly you define that epsilon 1 to epsilon 3, epsilon 4 like this, so on, epsilon k. So now the step is, so read it, this step. Now select all such bi's such that corresponding epsilon will become add up to 0 vector. That means pick some elements, means you from this set, this is set n, pick few elements. You pick some elements. Okay, pick some elements means, let's say I have picked randomly 3 elements. Let name it as B5, B8 and B13. If I pick these 3 numbers, when I come okay, that is what we mean by picking. Okay, this you can understand bacha thing only. When you pick few elements, their corresponding epsilon vector should be, when we sum it should equals to 0. You got my point, what I meant to say. Pick few elements such that add all its epsilon I vectors. Okay, so if you add all epsilon I vectors, then it should become, actually it should become some vector. On that vector, if you again apply mod 2, it should become 0 vector. What do you mean by 0 vector? Means in a vector we are having h components. What? How many? 1, 2, 3, so h component. So all those components are 0 numbers. Samjha? This is what they want to say it. Okay. From this, out of all k numbers, our interest only few numbers. So what is the specialty of few numbers? The specialty of few numbers is that pick few elements such that all the corresponding epsilon I vectors should add up to the, when apply on subject to mod 2, apply 0. Means suppose if I pick up all the 6 numbers and I have done the epsilon, means I have done, let's say I have picked 3 elements. Let's say B1, B2, B1, B10, B20. So when I sum up, means epsilon I1 bar, epsilon 10 bar, epsilon 20 bar, I got the value, let's say 2, 4, 10. Let's say I am taking only 3 components. Samjha? Only 3 components. Now apply this this vector on mod 2. So what do you mean by this vector on mod 2? Apply means as per my notation, just for simplicity I have written. So to apply for each, so 0 comma 0 comma 0. So this is called 0 vector. Generally 0 vector, so this is 0 vector. Just to differentiate 0 vector, we will write in some oval shape little bit. Okay, no problem. It's normally linear algebra things. Leave about it. It's so stupid notations, you can feel like that if you don't got it. Okay, so after these elements, okay, now see, initially we are having k elements. After that we have picked some elements such that epsilon I become 0. Now what you have to do? Now multiply all those such numbers. What? Multiply all those such numbers. So actually from a set n, from set n, set means having k bk numbers total. From this set you pick a few elements. Few elements such that epsilon I becomes 0 vector. Okay, now you are having, let's say, set let's say n1, few numbers. Now what you are doing is multiply all those elements in the set 1. So this is how I am writing. Multiply all those numbers means bi square, not elements. I mean, what I mean to say means multiply all of this corresponding this b layer of b1 square like this. Okay, see, once again I am telling here, the hidden thing is that this one you have to, like this you have to think, a layer of b1 square mod n means every time SAR cannot write a layer of b1 mod square, but you have to think okay, it is there. Okay, you multiply all such those numbers, only such those numbers. Okay, that's it. Multiply all those such numbers. Okay, that's it. After multiplying all those such numbers, actually SAR is calling b1 square as a ai. Ai is equals to bi square, is calling like this. So then what will you get? You will get so here let's say I'm having like few numbers, something b1, b2 and so on, b10, b15. Then multiply all those such numbers. So b1 square, b2 square, b10 square, b15 square. So this can be written as how, like a1, a2, a10, a15. So this can be written as like of course p1 power something sigma alpha i1, okay, p2 into sigma alpha i2 and so on, bh into sigma alpha ih. Samjay, you understand my point? Like that you have to move on. You got my point? So you should not multiply all these numbers. No, you have to multiply. You have selected this set. No, the specialty of this set is if you add it all will become to 0 vector. Okay, that's it. Now now see, the beauty thing is that this can be written as how? Tell me. Epsilon 1 1, epsilon i1, epsilon 2i and so on, epsilon hi. This is what now, bro? What is sigma epsilon I bar means? Of course sigma is there, everyone, sigma is there. So basically what I mean to say means sigma epsilon I bar is nothing but sigma epsilon i1 and sigma epsilon 2i and so on, sigma epsilon h. But we know that alpha ij mod 2 is nothing but sigma alpha ij, something like that. So can I write like this from this? Sigma alpha I1, this whole mod 2, sigma alpha I2 whole mod, something like that, okay? And so sigma alpha I h I, sorry, I1 2i. Arey man, I'm confusing. I1, I2 and IH. I1, I2 and IH. Arey bro, these are small things. Just because I have to explain to my, means for all my friends, means some set of some friends, I am explaining very slowly, dead slowly, making a monster video again. Okay, so now since we are, this all is equals to 0 0 0 0, it's become 0 0, so that means individual components are 0. That means sigma alpha I1 mod 2 equals 0. So from this I can conclude that sigma alpha whole I is a what? Even number. So basically what I mean to say means, from all these things I can write like this: sigma alpha ij is a even number, where, okay, where j runs, I mean you can write like this, okay, where I runs to 1 to k. Samjha? This what like they have written here, I runs to something, okay. This is the even number. This see, this much you have to understand in this small line only, bro. You got my point too. One kick I will give you. This is what you have to like. I am not like every time you are like some BTech student. You have to understand these things. You have to understand. Okay, of course, this is not telling to everyone. To my some set of people. So this again, this much detail. If I go, then if I telling to some set of people, the other set of people will also ask. They will spit my mouth on my mouth. Arey man, why you are making dragging like this? I'm getting very sleepy, like that they will say. Okay, but anyhow, let it be. So well, again we are defining some alpha ij. Okay, some variable. What is that variable? I'm defining alpha ij 1 by 2 sigma I runs 1 to k. This is what I am defining, alpha ij. Let's say I defined it. So in mathematics, just for fun I am saying, in mathematics we will write like this. This indicates that this is the definition, not equals to, means of course equals to how, okay, over to the subject that it is a definition. Okay bro, you understand my point? This thing you have to understand. This is the definition. After that, so see, if you multiply all ai, means what I mean to say means pi ai is nothing but pi bi square, that is equals to pi of pj into whole power sigma I runs to 1 to k alpha j, where j equals to 1 to h. Okay, samjha? I mean what I mean to say is this one, p1 power sigma alpha I1, where I runs to 1 to k into p2 into sigma alpha I2, and so on, like this, blah 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 blah. So some dirty things. Okay, okay. Now since according to definition, just keep it this value, sigma alpha j is nothing but 2 into sigma ij. So replacing this value, what will you get? Two into, you know, a power mn equals to a power n. So can I write like this? See, this is pi is there, I am writing for this one inside value of pi, pj into gamma ij you got my point, gamma ij into whole square. And again, one beauty thing is that, let's say when I write generally, let's say some k1, k2, k1 square, k2 square, kt square, this can be written as pi of 1 2 3 ki square. So if you observe that this is same equals to k1 k2 k3 whole square, that is equals to pi of ki whole square. So this is the property. So this means you can move this square to outside of the pi. Okay, now I am writing like this, pj gamma ij whole square. Samjha, because of this property. So again, this thing also, like, you need to understand from directly from by looking on to this also cannot explain every time. Samjha? Okay, fine. So you got my point. So finally what happened, tell me? Pi ai equals to whole square. Okay. Now just square root on both sides. So pi ai into square root of pj gamma ij whole square. So it will become pi of pj gamma ij. So again I am defining it. Let's be ci. I am defining. Okay, let c be the number such that phi is equal to mod n. Okay. Means basically what I mean to say means ci, this is not ci is nothing but whatever you get value, again apply mod n to this. So let's say value, just for fun I am keeping, let's name it as some yes. Okay, yes. So the value ci is nothing but s mod n. Okay, s mod n. You understand my point, what I mean to say? So this is how what we define it. Just same as it is value, applying mod n, this value becomes ci. So after the next step, then so that is called least positive residue. I told again starting only difference between least absolute positive residue, least absolute residue, and least positive residue, same only. I mean, you understand my point? Okay, if you're not, once again go on see. It's now only it's becoming so long video. And okay, now this is how we will find the c. How to find c means, first from all these things you pick some elements and multiply this value, this. Okay, this is how you found it. So ci equals to pi of pj into gamma ij whole mod n. So how you find means, from initial set n of like k numbers, you have picked the sum n set n which is having epsilon vector becomes to 0, means summation of all epsilon I1 bar in this becomes 0. For that element you have multiply all the elements. This is Ci. Okay, now what? Now this n is nothing but what? b1 b2 b2 and 7 bk. Now multiply this value. Now I am defining small bi. What is that one? Small bi only. B. Hey bro, sorry, it is C. C ya C ya? C bro. Okay, chalo. It is C. It is C. Sorry, it is C. Okay. Now I'm defining. So again I'm defining. Multiply all these numbers and apply model. Bi whole model. This is the definition. So after finding all these things, means after finding, final step, after finding B, C, now check this value. Means if B equals to C, samjha, if B equals to C, then repeat whole process again, means from the begin, means change the set B means factor base, change the factor base set, sorry, not factor base, sorry bro, change the n means set of B numbers, take some other set of B numbers, okay, and do the procedure. If B not equals to C, now wait, array man. So first after this one, now check this value, whether B square is congruent to C square model. So this can be, I have told this congruence property, that, sorry, excuse me, that is, this can be written as B square model okay, nice. So this is what means, this will satisfy, okay, if not satisfy then this has to satisfy, okay. This will satisfy. After this satisfy, there are two conditions. If B equals to C, means exact B, what I mean to say means exact B means this value, exact C is this value. If B equals to C, then what will happening? Repeat the whole process again. If B not equals to C, first this one has to happen pakka, means it has to happen, means you have to check, after checking that, again there are sub cases, B equals to B. If Y not equals to C, then stop the algorithm, means stop the process and report the factors. That's it. Okay, in next video we will take one example and again we will deeply investigate it. Don't worry, for just now, for this now, you just understand this theorem. Okay, it's saying that thus B and C can be considered in different ways whose squares are congruent to each other under modulo m, that is C square is equals to B square model. Okay, this one you have to remember it. That's it. Okay, for more clarity, since we will do solve example, no, in that you will understand like all this whatever I explained it betterly, and how to find factor, means I didn't tell, I am stopping this one, time has become very large. I am stopping means after this process how to find the factor, means the whole intention of what is the purpose. The purpose is to find that factors. No, fermat factorization means what? Given a n value, give me two factors, a into b. This is what fermat factorization whole topic is about, that we will discuss next. Okay, thank you, bye bye. If you really like my, after listening, if you really feel this is like 50% informative, like wherever you see me, or comment down Jai Sri Krishna. Okay, thank you, bye bye.